In this video, we'll be looking at the nomenclature of alkanes and alkyls. Now, before we go into details, we need first to understand what are the alkanes and what are the alkyls. So, now, alkanes are saturated hydrocarbons containing only single bond, carbon to carbon. So, anything that is having carbon to carbon, single bond, it is being referred to be saturated hydrocarbons. And their general formula, it is C₃H₂N plus 2. That's the general formula for the alkanes. But when you come to this side, which says alkyls, so alkyls are formed when one hydrogen atom is removed from what? Alkanes. So if we have removed one hydrogen from the alkane, meaning that one now, that group has changed to be alkyl group. And the general formula, it is CnH2n plus 1. That's the general formula. Now, let's look at how they are being represented in the formula. So if you look at these ones, the first 10 alkanes, the one with the one carbon, it is known as the methane. Now, after removing one hydrogen from methane, here there are 4 hydrogens. After removing one hydrogen from methane, it becomes what we call methyl. So on methyl, it is C₃H₃, like that. That's what we call alkyl group. So let's also go to the second one. On the second one, we have the one with 2 carbons. It is known as the ethane on the alkanes. It's known as the ethane. But when you go to the other side, to the alkyl group, it will be referred to be ethyl. Why is it to be referred to be ethyl? Because we have removed one hydrogen from the ethane, which is here we're having 6 hydrogens. But when you go to the ethyl, we're having how many hydrogens? 5 hydrogens. How about the propane? Propane is also the same. Propane, this side is propane with 3 carbons and 8 hydrogen. But when you go to this side, it is refers to be what? Propyl after removing one hydrogen. So we are only just removing the hydrogen. We are not removing the carbon. So we're just removing the what? The hydrogen only. How about the butane? The butane, it is also the same. Butane is C₄H₄, then H10. But after removing one hydrogen, it becomes C₄H, then H9. So we have removed one hydrogen. Okay, let's also go to the one which is having 10 carbons. The one which is having 10 carbons is what is known as decane. So since it's decane, it has C10, then H22. But when you go to this side, it is decyl. So decyl, it is having C10 and H22. So that is what we call decyl. So we have differentiated between the alkanes and the alkyls. Now let's go on the skeletal presentation of these ones, which are known as what? Alkanes and alkyls. So the skeletal presentations of alkanes and alkyls. Let's first go to what we call ethane. So ethane, it is C₂H₆, like that. Now, here we need to know the condensed formula for you to be able to draw the skeletal structure of ethane. So, ethane, the way it is C, that's the structure, right? Like that. That's the structure of what? Ethane. the display structure in short of ethane. It looks like that, right? Now, for you to write the condensed structure of ethane, what you do, you get this part and this part alone. So here on carbon number 1, how many hydrogens that are there? There are 3. How many hydrogens which are there again? There are also what? 3, like that, right? Okay. Now, this formula that we have write, it is what is known as the condensed formula. So after writing the condensed formula, now we can draw the skeletal presentation of ethane. So how it will be? It will be just like 1, now a sleeping 1. So at the end here, this part at the end, and at the end this part at the end, this side again, at the end this part, these ones are being referred to be C₃. C₃. So every end of a skeletal structure, it is C₃. So meaning this side again is C₃, and also this side is what? C₃. So that is the skeletal structure of the ethane. Now, when we take this ethane to what we know as the ethyl, let's remove 1 hydrogen from there. It will be C₄H₅. After we have removed what? 1 hydrogen from there. So, what will be the condensed structure? The condensed structure will be C₃ and C₄, such that when you add 3 plus 2, it will give us 5, which is here. So for you to draw the skeletal structure for ethyl, you know what you do? We do like this. This is C₃, then this side here to be C₄. So for you to show that I have removed 1 hydrogen from the ethyl, you put something like this. This is what you put, something that has been cut off. So this side you have shown that we have cut off 1 hydrogen from the ethyl. So that's what it will present there. Okay, let's move to the second one. Let's move to the second one, which is propane. So propane, it is C₃, like that. Then here what? 8. That's what we call propyl. So what do we do here for you to write the condensed structure? Just say C₃, then C₄, then C₃. How many carbons? 1, 2, 3. So there are 3 carbons. That's why I've just said 1, 2, 3. These are 3 what? Carbons, like that. For you to write the skeletal structure for the propane, you just do this. So carbon number 1, it is on this point. This is where carbon number 1 is. Carbon number 2, it is on this point. Then carbon number 3, it is on this point. Just like that. Now, but when it comes to this side, propyl is what? C₃, then H₃, like that. So the condensed structure, it is C₃, C₃H₁₂, then C₃H₁₂. Now for you to write the propyl group, what you do is, or for you to write the propyl skeletal presentation, what you do is you say this one here, right? So this is carbon number 1, carbon number 2, then carbon number 3. So you draw all of them like 3. 1, 2, 3. We have drawn, right? So now for you to show that I've removed one hydrogen from this side, then you do this, then you do this. So this side here, it has shown that we have removed one hydrogen. So this is what is known as a propyl skeletal structure, which is here. Okay, let's also try what is known as a butane. So when you talk about butane, butane has a formula which is C₄, then H₆, like that, right? The condensed structure, just a C, how many C's? 4. You do this, right? Remember, every time at the last point is C₄H₃. Again, this side is what? C₄H₃ for the alkane. Then here it is what? The between ones are what? C₄, C₄, like that. So what you do, you have to say the condensed structure, right? Now here, 1, 2, 3. Then what? 4. This is how it looks like. That's a skeletal structure of what? Butane. But when it goes to what we call butyl, things change. The condensed structure, it is C₄H₃, C₄H₂, then C₄H₁₂, then also C₄H₁₂. We have removed one hydrogen, which is this side. After removing one hydrogen, then what you do for you to write the skeletal structure now, it will be, you write all of them 4. 1, 2, 3, 4. Now, for me to write the butyl, to show that I've removed one hydrogen, what I'll do is that I'll put it down here, then I'll put something like that. This is what you'll be seeing. So this is what you're seeing there. This is a thing that which is here. It shows that we have cut one hydrogen from the butane. So that is how we do it on that one. Okay, now also let's on ourselves, let's try pentane. Let's try pentane. So I've given you 3 minutes to see if you can manage to draw pentane. Okay, let's compare now the answers. So on pentane, we're having C5, then here 12, like that. So what you do here is the condensed structure is C₄H3 and C₄H2, C₄H2 and C₄H₂. This is 1, 2, 3, then 4. Then C₄H₁₃, then 5. So this means you will have just to say 1 there, that is 1, 1, 2, 3, 4. Then what? 5. Just like that, right? This is what we call pentane. Now, how about pentyl? So pentyl, it is CH3, CH2, 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 again CH2. So what you do, you have to say, you have to draw like that. 1, 2, 3, 4, 5. Then you do like that. This is what we call pentyl. Okay, we need to practice as much as we can so that when it comes, we are not supposed to struggle. No. Okay, how about hexane? Hexane, it is C6, then H, H14, like that, right? So you just do this 1 2 3 4 5, then 6. This is 6. How about hexyl? Hexyl, remember the formula to be C₃H what? To be H13, like that. So what you do, you just say 1 2 3 4. This is 4 5, then 6 here. 1 2 3 4 5 6, like that, right? Then as if maybe I'd want to draw it for the 7th one, and we do this. This is what we call hexyl. So what we need to understand is that the starting point of hexane is C₃. The ending point again, it is what? C₃. But on the corners here, we have C₄. Here again what? C₄. Here again we have C₄. Here again we have C₄. That's what it means. Okay, now let's go to what we call naming. About, you have to know how to name both of them. Now be putting together between alkanes and alkyls. So here there are some basic rules that you need to understand in terms of naming, because you can't just name anything without rules. So you need to have rules in order for you to able to name correctly. So in this question, I have some these rules which are what we call basic rules. These are basic rules for naming alkanes and what? Alkyls. So we'll be putting them what? Together. So the first thing that you do is find the longest continuous carbon chain. So when you find the longest continuous carbon chain, that is being referred to be what we call parental name. So the longest chain, it is what we call the parental what? Name, or the parent name, right? And the second thing is number the chain to give substitutes the lowest number, or in another way, make sure that the branches that are connecting to the parent, they are supposed to have the lowest what? Number, or they're supposed to be closer to the end of the carbon chain. And the other one is identify and name the substitute as alkyl groups. So every branch that is on the long chain, or that is on the carbon chain, or what that is on the parent chain, is supposed to be referred to be as what? Alkyl group. So every substitution that is on the longest chain, they are supposed to be referred to be what we call alkyl group. Okay. Rule number 4, indicate the position numbers before the what? Substitution names. So what you do is that we need to indicate the numbers. So indicating the numbers of the substitution, what do I mean? If the substitute is on the position number 2, on the carbon number 2, I have to say 2, then a name. I don't know if it's ethyl, methyl, just like that. That's what it means. Then the other one, use the prefix di, tri, tetra for identical groups. So if the branches are the same, what you need to understand is that we need to use di, meaning that there are 2 branches which are the same, tri, meaning that 3 branches which are the same, which are 3. If I say tetra, meaning there are 4 branches which are the same, that's why I have to say what? Tetra. Okay. Then rule number 6, arrange the substitute in alphabetic order. Make sure whatever you're writing is supposed to be in what? Alphabetic order, if we're having a lot of branches, or the substitute. So the substitute, other name I can say just what? Branches. So these are the rules that we need to take note when we are answering this. Now let's try to name something here. For example, this. So this is butane, right? Why I'm saying this is butane? Because it has how many carbons? So we have first carbon here, second carbon here, third carbon here, and fourth carbon. So this is 1, 2, 3, 4. That's why I've said this is what we call butane, right? Now, the name will change if it is like this. We have a substitute here. If I had to count, this is 1, this is 2, this is 3, and this is 4. Now, the end here, it's C₃. Here it is what? C₄H. Here it is in C₄. Here it is what? C₄. If you look at this is C₄, like that. Now, if you look at that, right, we have a branch or a substitute, which is here, right? Now, when you're naming this, according to the rules, they have said that the branches or the substitutes, they're supposed to have the lowest number. Or just check this branch here, it is near to which end? This is the ending, right? The end, it's very near to this, but it's very far to the other end. So if I start counting from this side, I'll say 1, 2, 3. So it means that this branch is on carbon number what? 3. Now that would be wrong because it is very far, or the number which is here, it is very big, because according to the rules, they've said that we need to put the branches on the lowest what? Number. So this means that we need to start from this side. So we have to say 1, this side would be 2. Here it was 3 when I started this side, now it has become what? 2. So meaning that I have to start counting from this side where it is near to the end. So this is 2, then this one what? 3, this is what? 4. Now, what is the name of this branch? So if you look at that, that is C₃. What is C₃? Methyl. And methyl, it's on carbon number what? It's on carbon number 2. So you say 2-methyl, like that. What is the name? Everything. How many carbons which are there on the longest chain? It is, they have about 4 carbons. So it will be 2-methyl butane. That's what it means. Okay. Let's also practice the other one. So what is the name of this? This is 1, 2, 3, 4, 5. How many carbons which are present? There are just 1, 2, 3, 4, then 5. There are 5 carbons. So if there are 5 carbons, what's the name? The name is pentane. But in a situation now that is like this, right? So if I may to count this, I know it's pentane, but it's having a branch or a substitute. So if you look at the substitute, this is the substitute which is here, right? So this substitute, here it is C₃, here it is C₄, what? 2, here it is C₄. Here it will be what? C₄, here it will be C₄. So at the end here, is C₄H what? 3, like that. So we're having a branch which is here. This is the substitute or the branch, right? So if I start counting from this side, we need to make sure that this substitute is having the lowest what? Number, or the lowest, or it's supposed to be near to the end. So if I start counting from this side, this is 1, this is 2, 3, this is 4, this is 5. Even if I start counting from this side again, it will be the same because it will be 1, 2, 3. So at this branch, it's on branch number what? 3. So what you do is you say 3. What is the name of this branch? Remember the name of this branch. What's the name of this branch? The name of this branch, it will be what? So if you look at that, you shall see that the name of this branch here, it is methyl. So you say 3-methyl. What is the parent name? Everything. It's having 5 carbons, so it is 3-methyl pentane. So 3-methyl pentane. That's what it means. Okay, let's still practice. Now let's also look at this one. Now we're having 2 branches. So branches, we have this one. This is the branch. Again, this is also the what? The branch. 2 branches. If I start counting from this side, 1, 2, 3, 4. Even if I start counting from this side, 1, 2, 3, 4. This will be 3, this will be 2, meaning that it's just the same. There's no difference. So how many branches are we having? We are having 2 branches. At carbon what and carbon what, or the number what and number what, we're having at number 2 and number what? 3. So what you do here is you just say 2, 3. What are the name of these branches that we're seeing? The name of these branches that we're seeing are all of them, they are methyl. So how many methyls that we have? We have 2 methyls. So if we have 2 methyls, meaning that we'll say dimethyl. Why di? Because to show that there are 2 methyls. So you have to say dimethyl. What is the name of everything? It's butane. So the name of everything is what? Butane. Why butane? Because 1 here, 2, 3, then 4. So that's why I've said 2, 3 dibutane, like that. How about if I draw like this? I put this, I put it here, I put it here. So how many branches or the substitute that we have? We have 1, 2, 3. What are the name of these branches? The name of these branches are what we call, all of them, the methyls. On carbon number what and carbon number what. So we start counting. We can start counting from this side or this side, because branch number 2 here, again branch number 2. So meaning that we have to start counting from this side. So just say 1, 2, that is 2, 3, then what? 4, then what? 5. So we have branch number what? At 2 we have a substitute which is methyl. At 3 we have a substitute which is methyl. At 4 we have a substitute which is also methyl. So How many methyls that you are having? We are having about 3 methyls. So we say trimethyl. What is the name of everything? It's what we call pentane. Those are the things that we call them. Simple and straightforward. Okay, now let's also look into the other example. We need to practice as much as we can in order for us to be comfortable. We need to practice to have more knowledge. So let's also practice this one. So if you look at this is what we call this to be pentane. But if things changed to be like this, here what you do, you have to say 1, 2, 3, like that. Now, what are the branches that we having? This part here, if you look at this part, this is also the branch. And this part here, if you look, this is also the what? The branch. So we have the branch, we have the branch. So what are the name of this branch? The name of this branch are methyls. So since are the methyls, they are on carbon number what? Carbon number 2, right? So what you do, you say 2, 2. What? How many methyls? 2. So to be di what? Methyl propane. Straightforward, right? So that is how you answer that one. Okay, now let's try to answer this one. So if you look at this, first of all, let's look for the longest chain. Which one is the longest chain? 1 here, 2, 3, 4, 5. Right? So we have this, that's the longest chain, right? Even if I start counting from here, it will be the same because it will be 1, 2, 3 here. So here still to come out to be 3 because this is what? Number 3 carbons. Even if I start counting from this side, it will be the same. Now, if I may ask you, what is the name of this branch? So the name of this branch, how many carbons which are here? Here we have a carbon. Here again we have a carbon. So here it is CH3. This is CH what? 2. So CH3 and CH2. What is this? This is what we call ethyl. Right? So we have discovered that the branch name, it is the ethyl, or the substitute name is the ethyl. So on the longest chain, it's on carbon number what? On the longest chain is on carbon number 3. So you have to say 3 ethyl. Then what? Then 10. Straightforward and simple. That's how you answer that question. Okay, let's also look into the other one. Let's also look into the other one. Just imagine we have something that is like this. Right? Now, the question is, where do we start counting from? This is a situation where we have to start counting from the side using the what? The alphabetical order. Right? If I may ask, what is the name of this branch? This is methyl. But what is the name of this branch? What's the name of this branch? What's the name of this branch? This is what? Ethyl. So I've just added these ones because if I left like that, meaning that the long chain will start from here. So I've added this so that the points should be the what? The same. Okay, now if I start counting from this side, this is 1, this is 2, this is 3. How about this side? 1, 2, 3. So which one is near to the end? Both of them there are on carbon what? 3. If I start counting this side, it's carbon number 3. If I start counting this side, it's on carbon number 3. So there's a danger there. What do? We follow the alphabet. So according to the alphabet, between M and E, which one comes first? The one which comes first, it is E. So you know what you do? We need to start counting from the side where it is having E. We are following now the alphabet. So we have to say 1, 2, 3, 4. This side would be 5. Then 6. This side would be what? 7. Now when naming, we have to still start with the alphabet. So in naming, we have to say on carbon number what, where there's ethyl? 3. So we say 3 ethyl. On carbon number what, where is having methyl? Carbon 5. So we say 5 what? Methyl. What is the name of everything? It's having 7 carbons. So we have to say that is what we call heptane. So your answer is 3 ethyl, then 5 methyl, then heptane. That's what it means. Simple and straightforward. Okay, let me put more examples about the same one. I'll put one here like this. I'll do the same again. I'll do this here like this. So in this situation, how about in this situation? How many branches are we having? We're having about 3 branches. So this is the first branch, this one, and this one. What's the name of this branch? Methyl. What's the name of this branch? Methyl. But what is the name of this branch here? This is not methyl because we're having 1 and 2. So this is what known as what? Ethyl. So now, where are we supposed to start counting from? Check the branch which is near to the end. This side is where the branch is near to the end, but this side is very far. So we need to start counting from this side. This is 1, 2, 3, 4, 5, and 6. We're having about 6 of them, right? So since it's 6, we have to say we need to start, right? So the way we start here, we follow the alphabet. It will be 4 ethyl, then 2, 3 dimethyl, then what? Hexane. Why did I start with the ethyl? Because ethyl, that's a name, but if I say di, I just meant 2. What is the real name? The real name starts with methyl. So meaning that this di is not considered to be the first on the alphabet because it is just a name which is given to show that there are two, but the real name is methyl. So that's how we answer that one. Okay, how about if I have something that is like this, like this. So again, you also do the same thing. Where it is the end, where is it showing that this side is the ending part? Where is it showing that this side is the ending part? So if you look, if I start counting from this side, will this give me the lowest carbon number? No, because this side is on carbon number 3. But if I check this side, this is 1, 2, 3 again. So we have 1 here, 2, 3. How about this side? 1, 2, 3. We have methyl and ethyl. So which side are we supposed to start counting? It's this side. So we say 1 here. Why I'm saying this side? Because it's ethyl. So you have to follow the alphabet. So it's ethyl like that. So it will be 1, 2, 3, 4, 5, then 6, then what? 7, like that. So we have ethyl. So we have to say the name would be what? 3-ethyl. Then what? 4. What is this name? What is this name? How many carbons? 1, 2, 3. So there are 3 carbons on this branch. So meaning that that is what? Propyl. Then what's this name? On carbon number 5? That's methyl. So it would be 5-methyl. Then what's everything? That's heptane. Straightforward like that. Okay, let's look at this one. It's a bit complicated, but it's not that complicated. So if you look at this, how can you name this one? If I start counting from this side, 1, 2, 3, 4, 5, 6. There are 6. Now, can I say that this is my longest chain? No, because here it's what? Giving me what? 3. But if I start counting from this side, 1, 2, 3, 4. Here it is 4 now. So meaning that this is the longest chain. Then it will be what? 5, then what? 6, 7. Right? And what is the name of this? That's ethyl. Ethyl on carbon number what? 4. So it will be ethyl. 4 ethyl. What that? Heptane. Just like that. Straightforward, right? Okay. Now, how about if we have something real now, like this? What name can you give to this? So on this one, this is 1, this is 2, this is 3, this is 4, this is 5. So what you do here is you check out this branch, right? We take like this. That's the first branch, right? So what you do is you say this is the point, this is 1, and this is what? 2. So what's the name of this? That's ethyl, right? Just this part alone. I'm saying just this part alone. This name is what? Ethyl, because you have 1, 2. I've left this one which is this side. This is ethyl. Okay, now this ethyl, it's connecting at what? Oh, this part, in short, let me just put like this part here. the brighter color. Let me just use this one. This part here, it's in ethyl, right? So it is 1, 2. That's why I'm saying that this part is what? Ethyl. Now, how about this one? What name can you give to this? Methyl. And this methyl in here, it's connected where? At 1. So it is 1, like that, right? Methyl. The parent name of this part? Ethyl. So what you do is, for you to name that, you will say 3, 1, 1, methyl, then ethyl. What is everything? Pentane. That's how we name it. Right? Okay. Let's do the last one. Okay. So in this situation, what do we do in this situation? In this situation, we need to look out for the longest chain, right? So how we look out for the longest chain, we do like this. So this is 1, this is 2, 3, 4, 5, 6, 7, then 8, then 9. So that is the longest what? Chain in here, right? So since this is the longest chain, which is in here, so what you do here is that, what are the main branches that we have? We have this branch and we have also this branch. What are the name of these? All of them ethyls. So what you do, you say 3, 4 di methyl. What's that? Nonene. Simple, like that. Okay, now let's do the 2, which is these ones. Now if you look at these ones, we have bromine and chlorine this side. So here between B and C, which one comes the first? It's B. So meaning that counting, we need to start counting from this side using the alphabet. So we have to start counting from this side. This is 1, this is what? 2, this is 3, this is 4. So there, meaning it will be 2 bromo, then 3 chloro. Everything together, butane. Simple and straightforward. So that is how you answer this one. Okay, let's also look at the other one. So we have bromine, bromine. So what you do, 1, 2, 3, 4. So what you have is 2, 3. How many bromine? 2. So you have to say di bromo. I've said di what? Bromo. 2, 3. Then di bromo. Brom what? Butane. So we only follow the alphabet. So the next time we'll be looking into the naming part about the secondary, tertiary, and so on. Make sure you subscribe, comment, like, share.